Okay, let's review for your test. Again, don't forget that you get to use your packet on the test. That is mostly important because you're going to want that conversion page that is on the very front page of your packet. Okay, you're going to want that to do these conversions. Okay, so problem number 1, kilometers to meters. Okay, so we are going to start with set up our little T-chart thing right here. Okay, so we have 8 kilometers. And we want to get that to meters. Well, according to our conversion chart, there are 1,000 meters in every 1 kilometer. Okay, remember, you want the one that you are starting with to cancel out, so you want to put them on opposite sides of the fraction. Okay, so 8 kilometers and the other kilometers on the bottom, so they cancel out. So when you multiply across the top, you are left with 8,000 over 1, which is 8,000, and you are left with meters as your unit of measure. Okay, 72 inches to feet. Okay, that is a straight one-step conversion. The inches has to be on the bottom, and I'm trying to get to feet. Okay, so then ask yourself, how do feet and inches relate? Well, I know that there's 12 inches for every 1 foot. Okay, 12 inches for every 1 foot. Multiply across the top. Multiply across the bottom. And then simplify. So 72 divided by 12. You are left with 6. The inches cancel. So you are left with 6 feet. Okay, the next one. You are throwing a party and you want to buy 15 pizzas. Each piece of pizza costs $7.25. How much will you pay to purchase pizza? Okay, seems like a super easy question, and guess what? It is. 15 pizzas at $7.25 each. You are looking at $108.75. Okay, how accurately should the measurement of the width, which is the thickness of a pencil, be measured? Okay, think about a pencil. Okay, inch would be way too big. Half inch would also probably be way too big. Okay, quarter inch would possibly work, but when we are talking about something as small as the width of a pencil, 1/8 of an inch is probably what you want to work with. Okay, be careful with the wording of this one. A classroom has a length of 10 yards and a width of 20 feet. What is the area of the classroom in square feet? Well, I have 2 different measurements here. Okay, one of them is already in feet, and you know the area is length times width. Okay, my width is already in feet. My area is not, or my length is not. So I need to convert that 10 yards into feet before I do anything else. Okay, 10 yards, and I'm trying to get to feet. Yards on the bottom so that they cancel out. The relationship between feet and yards is that there's 3 feet in every 1 yard. Across the top, 10 times 3 is 30. Over 1, so I have 30 feet. Okay, so that is my new length, so now I can actually get the area. Okay, so I have 30 times 20 which is 600 square feet. Okay, for this next one, we are going to replace these variables right here with whatever they tell us each part is. Okay, so listen, sounds super complicated, but force is equal to m times a, which is mass and acceleration. Okay, if we measure mass in kilograms, so I'm going to replace this m with kilograms. Okay, and we measure acceleration in this equation right here. Okay, so instead of the a, I'm going to replace that with that equation. Kilograms over seconds squared. Okay, what is the unit for force? Okay, so basically we have to simplify this. I have 2 kilograms and that, so when I simplify, my unit for force is kilograms squared over seconds squared. Okay, same thing here. Number 7, we are replacing these variables with the measures they tell us. Okay, so I have d, distance is rate times time. Okay, and it tells me that rate is measured in meters. And my time is measured in seconds. Okay, so my distance measurement is right there, meters per second. Okay, number 8, here comes some more of our conversions. You can drive 100 yards in 1 minute. Convert this to yards per second. So we have 2 different conversions happening, but they can happen at the same time. Okay, let's do our yards first. We are trying to get from yards to, oh, never mind, we're doing 1 conversion. We're just going from minutes to seconds. Okay, so the yards can say, but we're trying to get minutes changed to seconds. Okay, remember I had to put the minutes on top because I want these 2 to cancel out. Okay, now think of your minutes and seconds relationship, and there are 60 seconds in every 1 minute. Okay, the minutes canceled, I'm left with yards and seconds, which is exactly what I want to be left with. So multiply across the top, multiply across the bottom, and simplify. So you are left with 16.67 yards per second. Okay, you have an apple tree in your backyard, 1.6 pecks each day. How many liters do you collect in 1 week? It gives you most of the conversions that you need. Okay, all we really have to do is fill in this section right here. Okay, so they went from, the pecks cancel out. Okay, my days are going to cancel out. Okay, so I have to figure out what goes right here. Okay, and it's probably going to be, I'm trying to get to liters, so it's going to be my liters conversions. Okay, liters to quarts conversion. Okay, so my quarts has to go on the bottom because I want it to cancel out with this quart. Okay, and I have 1 liter for every 1.06 quarts. And again, multiply across the top. So I have 1.6 times 32 times 1 times 7. So I get 358.4. And then on the bottom, I have 1 times 4 times 1.06 times 1. So 4.24 on the bottom. Okay, check your conversions and make sure you are left with the only 2 things that you want. Okay, and they want liters and weeks, which is exactly what I'm left with. When I divide, I end up with 84.53 liters per week. Okay, number 10, same thing. You are going from gallons per day, and they want you to change that to pints per second. Okay, so let's see. We have 50 gallons. For 1 day. Okay, let's change our gallons to pints first. Okay, so with your little conversion chart, let's see. Gallons to pints first. Okay, I'm going to have to make 2 steps. I'm going to have to go gallons to quarts and then quarts to pints. Okay, so gallon to quart first. And that relationship is there's 1 gallon for every 4 quarts. And then quarts on the bottom, pints on the top. And that relationship is there's 1 quart for every 2 pints. Okay, so let's see if that eliminates these guys and leave me with what I want, and it does. Okay, so now let's change our time measurement. So instead of days, we're going from days all the way to seconds. Okay, so let's go from days to hours. Then from hours to minutes. And then finally from minutes to seconds. Okay, a lot of work there, but let's make sure everybody cancels out. Hours, pints per second, yes. Okay, now let's set up these ratios. There is 24 hours in 1 day. There is 60 minutes in 1 hour. And there is 60 seconds in 1 minute. Okay, now for the multiplying. Again, straight across the top. So 50 times 4 times 2 times 1 times 1 times 1. So you have 400 on top. One times 24 times 60 times 60. And a big old number on the bottom. Okay, so when we simplify that, 400 over 86400. Make sure that is a fraction just because it looks better. Or let's just put it as a decimal, why not? 0.00 rounds to 5 pints per second. Okay, next one. A train travels at 80 miles in 2 hours. What is the train's speed in feet per second? So again, we have two different conversions to do. We have to go from miles to feet and then hours to seconds. Okay, so right now we have 80 miles. In 2 hours. Okay, let's do our miles to feet conversion first, just because it is one step. Okay, miles to feet. According to your conversion chart, there are 500, 280 feet in every 1 mile. Okay, so that eliminates our miles conversion and leaves us with feet, which is what we want. Okay, now from hours, we have to get to seconds. So hours is going up here so that they cancel. Hours to minutes. And then we can go from minutes to seconds. Okay, there is 60 minutes in every 1 hour. And there are 60 seconds in every 1 minute. So let's make sure all these conversions cancel and leave us with feet per second, which is exactly what we wanted it to leave us with. Okay, so multiply across the top. 80 times 52, 80 times 1 times 1. So that leaves us with 422,400 on the top. 2 times 1 times 60 times 60, which is 7,200 on the bottom. Okay, and when you simplify that, you get about 58.67 feet per second. Okay, what unit rate would be used to describe the temperature change? Okay, think of this as slope, remember. Okay, slope is rise over run, or our y over our x. So in this situation, our y looks like dollars, and our x is degrees Celsius. So we are talking about dollars per degree Celsius. Okay, number 13. Okay, we are simplifying these radicals. Okay, so I need to think of two numbers that multiplied to give me 18. I have 9 and 2. Oops. Okay, the square root of 9 and the square root of 2. Okay, I know what the square root of 9 is. The square root of 9 is 3. And square root of 2 does not simplify, so there is your simplified version. Okay, the next one, 250, we have the square root of 25 times the square root of 10. Okay, the square root of 25 is 5. The square root of 10 does not simplify any further, so it's 5 square roots of 10. And the next one already has a number out to the front, so I'm going to put him down here so I remember to use him in a second. Okay, so square root of 68. Let's do Square root of 4 times the square root of 17. Okay, the square root of 4 is 2. Square root of 17 does not simplify. So we have 3 times 2, which is 6 square roots of 17. Okay, square root of 81 is a perfect square, so the square root of 81 is 9. Okay, for 17, remember, in order to add radicals, the number under the radical has to be the same, so we're going to have to simplify both of these. Okay, so 3 square roots of 12. Let's see what that'll give us. Okay, the square root of 12 can be broken down into the square root of 4 times the square root of 3. I already have my 3 on the outside. The square root of 4 is 2, and I'm left with square root of 3. Okay, so I'm done with 1. I end up with 6 square roots of 3 plus, let's do the other one. Okay, the square root of 27 is the square root of 9 times the square root of 3. Okay, the square root of 9 is 3. Square roots of 3. Okay, now that our radicals are the same, remember to think of this as combining like terms. Let's say this was a 6x plus a 3x. So 6 and 3, this simplifies to be 9 square roots of 3. Okay, number 18, again, a subtraction, so we have to do the same thing we did up here. We cannot add or subtract these unless they are the same. Okay, so let's do 54 first. The square root of 54 can be the square root of 9 times the square root of 6. Okay, the square root of 9 is 3. Square root of 6 does not break down anymore. Okay, so we have 3 square roots of 6 minus, and let's do the square root of 24. Okay, we have the square root of 4 times the square root of 6. Okay, the square root of 4 is 2. Square roots of 6. So when we simplify 3 minus 2, we end up with 1 square root of 6. Okay, when we multiply, remember the outsides go with the outsides, the insides with the insides, and then we'll simplify from there. Okay, so we have 6 times 7, which is 42. That's our outside number. And our inside number is 12 times 18, which is 216. Okay, so now let's try to think of some things that multiply to give us 216. Let's try some perfect squares first. So I'm going to try 16, 4, let's try 36, and that worked. Okay, so I have 42 that's already out here. And the square root of 216 can be rewritten as the square root of 36 times the square root of 6. Okay, the square root of 36 is 6. So 42 times 6, I have 252 square roots of 6. Okay, number 20, is the sum of the square root of 5 plus 4.7 rational? Okay, remember rational means basically does it make money? Okay, can you give that as a dollar amount to somebody is the easiest way to determine if something is rational or irrational. Also, if you press the math button in your calculator and try to change it to a fraction, if it will convert to a fraction, then it is rational. Okay, so let's type this in our calculator. So the square root of 5 plus 4.7. Okay, so when I put that in my calculator, I end up with 6.936067977. So the answer is no, it is not rational. Okay, this is not a dollar amount that you could give to. Okay, so we're going to do the same thing with this one, except it is multiplying. Okay, so the square root of 64 times the square root of 3. That gives us 13.856400646. Okay, so again, that is irrational. Okay, the question is it irrational? Yes, it is irrational. Okay, the next one, 2 minus the square root of 3. Okay, 2 minus the square root of 3. Again, it gives you a crazy long decimal. Not something we can convert to a fraction. Not something we can make into a dollar amount. Unless we round, which is not what we want to do. Okay, so this one is also irrational. Okay, how do you determine if a number is irrational? Okay, my method, if you cannot change it to a fraction, or if you cannot make a dollar amount out of it. Okay? All right, 24, find the perimeter. Okay, the first thing we have to do is we have to finish filling in these sides. Okay, if one side is the square root of 20, then the opposite side of that is also square root of 20. Same thing here, the square root of 45 and the square root of 45. Okay, so in order to add these together, okay, we are going to have the square root of 45 plus the square root of 45 plus the square root of 20 plus the square root of 20. Okay, none of those radicals match, so we have to simplify the square root of 45 and the square root of 20 and see if they give us stuff that matches. Okay, then we can come back and replace and try to simplify. Okay, so I'm going to come over here and do the square root of 45 first. Okay, that is actually 9 times the square root of 5. Okay, the square root of 9 is 3. Square roots of 5. And the square root of 20 can be rewritten as 4. Square root of 4 times the square root of 5, which is 2 square roots of 5. Okay, now we can come over here and replace these guys with what we just found their equivalent to be, and then we can add them together. Okay, so over here we said the square root of 45 was 3 square roots of 5. So we have 3 square roots of 5 plus 3 square roots of 5. And the square root of 20 is 2 square roots of 5. Okay, remember, when you are adding radicals, you do not add the radical. Okay, you treat it as if it was a 3x and a 3x and it became 6x's. Okay, so in this case I have 3 plus 3, which is 6, 7, 8, 10 square roots of 5 would be the perimeter of this rectangle. And the last one, okay, remember there's technically a 1 in front of this square root of 5. So we have 1 square roots of 5 minus 3 square roots of 5. Okay, 1 minus 3 is negative 2 square roots of 5. Okay, again, feel free to go back and watch any of the part of this review. Okay, pause it, rewind it, just go back on your own time and pull it up on YouTube, whatever you want to do. But you do have a test tomorrow. Good luck.